Welcome to classes on carboxylic acid, and it is practice set number 15, and there are a lot of questions answered on entrance exam which will be solved a bit later on. And specifically today I have taken the topic of the reactions and its solution of entrance exam question solution, reaction involving hydrogen of carboxylic acid and reaction involving OH of COOH group. So first of all, you please know some of the key part of the reactions which occurs in carboxylic acids. Then it will be very easy for you to understand the reaction. Otherwise, it will be very clumsy for you to learn all this by heart. So first of all, let us take a simple example of CH3. A simple carboxylic acid like this. And what are the different types of the reactions involved in carboxylic acid? Let us give a very schematic view on this fact. What is the schematic view? That is, first of all, the reactions involved with the backing of H of OH bond. A reaction involving hydrogen of OH bond, that is breaking of OH bond of carboxylic acid. Number one. Second type of the reaction, that is, first one is this, and second type of the reaction is involving of CO bond of OH, means it involves breaking of this. And third type of the reaction takes place on CO group is 3. Fourth type of the reaction takes place alkyl or aryl part attached with COOH. This is alkyl, maybe benzene, aryl part. If there is any reaction involved with hydrogen or any replacement of this, then on this type of the reaction is type 4. And the last type of the reaction is involving whole COOH as a whole is 5th. So these are the different schematic representation of the reaction taking place in carboxylic acid. Am I right? So out of all this type of the reaction takes place schematically, I will today discuss reaction of breaking of OH, H of OH of carboxylic acid and breaking of OH of carboxylic acid. So you minutely follow, and I hope you will find it easy to understand. So the entrance exam solutions the first of one is CH3COOH reacts with Grignard reagent. If you don't know the rule, you can't, because I previously at the very beginning I told you that I will deal with the breaking of H of OH of carboxylic acid. So here what's happened, carboxylic acid C double bond O and the bond in this way. So this is negative and this is positive, am I right? And this is Grignard reagent equal to CH3MgBr. And many of my classes, previous classes, I have told it that the carbon of Grignard reagent is minus and magnesium is plus. So very easily this minus get attached to this proton, gives you CH4, and finally MgCH3COBr is another part. Our concern is with this CH4. So when carboxylic acid reacts with Grignard reagent, it gives you hydrocarbon, means methane. So first question is over. Second one is carboxylic plus sodium hydrogen carbonate. So CH3 COOH plus NaHCO3. So here what's happened, and you know this part replaced by sodium, it is known to you all, CH3 COONA plus. This reaction seems to be very simple, but it is a bit hard because the question was not set up in this way. It was asked that carboxylic acid means acetic acid which acetic acid reacts with which one of the following compound to give you carbon dioxide? So acetic acid reacts mostly with sodium hydrogen carbonate to give carbon dioxide. Hence, this is a very important, very often in many different exam it comes that carboxylic acid reacts with the following compound to give you carbon dioxide. You are not asked to give this one carbon dioxide. So it very often gives sodium hydrogen carbonate. When it reacts with sodium hydrogen carbonate, it gives carbon dioxide. So it is very important reaction. Next question is, a colorless water soluble organic compound decomposes sodium carbonate and liberates carbon dioxide. It produces black PPT with tolerance. So first of all, the key point is the compound is colorless. So carboxylic acid, acetic acid, propanic acid, butanic acid, so chain increases. So lower carboxylic acids are very often soluble in water because of hydrogen bonding. But when the molecular mass increases, insolubility arises because it disrupts the hydrogen bonding. Because sometimes question asks when some lower carboxylic acids are soluble in water because of this. Answer: because of hydrogen bonding. So you are asked colorless water molecule means the carboxylic acid is lower one. Am I right? Where carbon number is less. Organic compound decomposes sodium carbonate and liberates carbon dioxide. Means it reacts with sodium hydrogen carbonate gives you carbon dioxide. Means it may be acidic, it may be formic acid. Am I right? But formic acid is more soluble than acetic acid. So formic acid liberates carbon dioxide and introduce black PPT with tolerance. Now what is tolerance? There is silver, ammoniacal silver nitrate solution, you know it, or you can write Ag2O. It is also tolerance. So it reacts with tolerance to give you Ag plus, and on oxidation it will give you some other compound. So our main target is that it is a carboxylic acid which reacts with tolerance reagent, and this tolerance reagent's color becomes on oxidized columns becomes Ag negative, it becomes black. And what is this organic compound? This organic compound is formic acid. Or question may come to you, acetic acid is also soluble. Why our answer is not acetic acid, why it is formic acid? Because acetic acid is also soluble, but when it reacts with tolerance reagent or ammoniacal silver nitrate solution, it does not give any PPT, it does not react. Because in carboxylic acid, only one carboxylic, that is formic acid, with reduced tolerance reagent becomes silver. Other organic acetic acid means CH3C double OH, CH3, CH2, C double OH will never reduce tolerance into silver. Because in oxalic acids, carboxylic acid, um, you can see that one of the important criteria of tolerance reagent to react is that it should have CHO group. So are there any C double OH group is there? H formic acid may be written in this way. So HC double OH. Am I right? So here you see there is HCHO. HC double bond O means this part. Only because of presence of this part in formic acid, it gives you or respond tolerance reagent. But in case of acetic acid, you will never get aldehyde of this type. Hence, other type of acid except formic acid will never respond to tolerance reagent. So your answer will be formic acid, means HC double OH. Next one is benzoic acid has less mass in water but in benzene it has more mass. Actually, in water and in benzene, there is a statement type of question in exam always asked whether the statement is correct or not. So if you justify this one, benzoic acid, say this is benzoic acid, and if this acid is made to react or placed in water, what happens? Just one CO molecule will release and it will be benzoate ion. Am I right? But what's happened when this benzoic acid is dissolves in benzene? So when this benzoic acid, so you see in water it dissolves in this way, so there is no more chances of changing in molecular mass of benzoic acid when it is mixed with water. But whenever it is mixed in benzene, means dissolved in organic solvent benzene, it dimerizes. So molecular mass of benzoic acid will become double due to dimerization in organic compound. So the molecular mass of benzoic acid in water is less than benzoic acid in benzene as it dimerizes in organic solvent. Hence, the statement is correct. Next one is uh, which one will evolve hydrogen gas with metal? Very simple, need not to explain much. It is alcohol. When it's react with sodium, it gives you C6H5, C2H5 or Na plus H2. And when it is acetic acid, CH3, COOH, when it is made to react with metal, again only metal sodium, it reacts with CH3, COO, Na plus hydrogen again. So which one will evolve hydrogen gas with metal? Which one will not evolve hydrogen gas with metal? So this two will give, but this one will not evolve. So benzoic acid will not give hydrogen gas. Acid with concentrated sulfuric acid. What is formic acid? Formic acid is this. When it is made to react with concentrated sulfuric acids, so what's happened, there is lone pair, so this will get attached. Am I right? So what will get, this is as like this, it will become positive. So on dehydration you will get HC double bond O plus water. Am I right? So if you arrange it in this way, in one step you can do, I will show you. So you can write HC double bond O and positive is here. Then this is removed and the bond is around arranged in this way. So you get this, means you are getting carbon monoxide out of this, you are getting carbon monoxide plus water. Mind that why this seems to be a very simple question, but when concentrated sulfuric acid is there, one of the important points should come in your mind, because concentrated sulfuric acid is dehydrating agent. It very easily tries to release water from the compound with which it is made to react. So with out of this we'll try to lose out water molecule. So very simply you see, if you just OH and H, this will give you what? Water. So what you get here is carbon monoxide is only. But sometimes very often very often the students gives carbon dioxide plus water, but from where you carbon dioxide get, they don't understand it in a very deep manner. That's why I have shown you with a bit mechanism, not totally exactly, that in the first step it is protonation, and in the second step the water is released since it is concentrated sulfuric acid, and then this cationic part is formed, and it is unstable. After this hydrogen is released, it gets stable, so you are getting carbon monoxide. So with OH and H release off, we are getting carbon monoxide plus water. It is also very important question asked in entrance exam. So this part is the reactions with involving OH of carboxylic acid. Am I right? So the carboxylic acid is this. Here we will just use the schematic representation. What the way I have shown you, that is there will be the breaking of COH bond. Am I right? So the previous question which I have or a bit earlier I told you that carboxylic acid when reacts with concentrated sulfuric acid, it gave carbon monoxide and water. This is nothing but the reactions which involves OH bond. So that point question should be in this scheme, reactions involving OH of carboxylic acid. So the next question is, say it is toluene when it oxidizes gives you A, on reacting with thionyl chloride SOCl2 it gives B. So answer is so since we are dealing with the reactions involved with OH of COOH, so first of all, it is known to us that when toluene or if there is CH3 except CH3 all on oxidation gives you carboxylic acid. So one at this point I am to mention you that if it is CH3 on oxidation with camenophore, it will give you this, and on this it will give you this, or if you, it is very important you need to know. So if you make to react this also, it will give you COOH. What is the length? It doesn't matter, but it matters only with number of hydrogen. If the carbon attached with the benzene ring has at least one hydrogen, that will give you carboxylic acid. But if say carbon attached having two hydrogen, carbon attached with having three hydrogen, carbon attached with benzene having one hydrogen, it will give you carboxylic acid. But at this point, if I tell you that if it is benzene, am I right? So if you use in this way, no hydrogen attached to the carbon which is attached with the benzene, if there is no hydrogen, it will not give any carboxylic acid, the reaction will not occur. So at this point, just keep it in your mind. Very often question asks, that is any alkyl part, carbon attached with benzene, if it has one hydrogen at least, it will give benzenic acid on oxidation, oxidizing agent camenophore. Am I right? Benzoic acid. So our concern with the OH carboxylic acid, so when ethyl chloride is there, so OH will be replaced by Cl. So benzene COCl. So this group is replaced by this. So our main objective is here replacement of OH of carboxylic acid. This is the answer. B is this. Am I right? B is this. So next question is CH3COOH PCl5. CH3COOH, just I have arranged it. So PCl5, again this OH will be replaced by CH3 C double bond of Cl. Am I right? Very simple. Next one is RCOOH PCl5 reacts with, gives you A, and A1 reacts with KCN gives B. B on Clemenson reduction and followed by hydrolysis gives you C. You are asked what is C. So you see R double bond OH means it is carboxylic acid. When it reacts with PCl5, we see that OH will be replaced by RC double bond of Cl. Am I right? So when this is your A, when this is made to react, this is made to react with cation, it is very simple. This is plus, this is minus. So this will be replaced by cation. So you are getting RC double of CN. Am I right? So that part I think any one of you can do. Means if PCl is OH, we are dealing with the replacement of OH of carboxylic acid. So when PCl5 is there, so OH will be replaced by Cl, and when KCN is there, alkyl halide, any halide and Cl part is replaced by Cn. Am I right? So RC of Cn. But here at this point, some critical point is there, Clemenson. You have got this in aldehyde and ketone chapter. So Clemenson, what is Clemenson? Zinc mercury in HCl. I have shown you the reagent, but just I am mentioning this one. But in the exam, it is given Clemenson. Means what the main fundamental fund of Clemenson reduction is that CO group in presence of this reagent means Clemenson will become CH2. So here you are getting this CH2 Cn in place of CO, that is Clemenson. And here at later point you are asked, it is on hydrolysis. Means hydrolysis, when you are asked followed by hydrolysis, generally that hydrolysis means acid hydrolysis, means water with acid hydrolysis is there. Hydrolysis means it is followed by hydrolysis, minutely follow whatever written in the arrow. It is acid hydrolysis means water and in presence of H plus acid, means here this CN group I have shown in many class earlier. CN on hydrolysis gives CuCOOH. So you please try to keep it in your mind, otherwise you can't answer it properly. So your C is this. So RCOOH equal to RCOPC, RCOCl, KCN is equal to Cn. Clemenson CO becomes CH2, means hydrocarbon will come here, and on acid hydro followed by acid hydrolysis, Cn will become COOH. So we get RCH2COOH. Am I right? So a bit hard because these are entrance exam solution. So minutely try to learn the trick so that you can find out. Here the trick is Cn on acid hydrolysis gives you COOH, nothing more. This trick is applied here. So now question number 4, carboxylic acid means CH3 C double bond OH, acetic acid, when made to react with thionyl chloride, answer A is formed. Again here the involvement of OH, breaking of OH. Here you are getting CH3 C double bond OCl. Already I have mentioned, I need not to explain again. But here you are asked benzene, and at this point you are asked to make reaction benzene and anhydride aluminum chloride. When benzene and anhydride hydrochloride is there, you should remind of Friedel-Crafts alkylation or acylation. Friedel-Crafts alkylation or acylation. Here it will be acyl, CO. Am I right? So it is known to you. So what's happened? Here benzene is there. When benzene is there means you will bring one benzene here, and when anhydride aluminum chloride is there, so what's happened here actually is CH3 COCl, and aluminum chloride is an electron deficient species, which is Lewis acid. Am I right? There is 6 pair of electron, 1 pair of electron is missing, so it will just withdraw 1 pair of electron here with chlorine. So you are getting CH3CO, an electrophile, and AlCl4 is unstable, will leave out in the reaction. So this electrophile will now enter here COCH3. So your answer is over. It is asked CH3 associated to benzene anhydride. Oh, yes. Again, again it is made to react with HCN. When it is made to react with HCN, so CN would very often react with here. Am I right? So it is electron deficiency center. Am I right? So this will be minus, this is plus, and this will get attached with here. So what you get here is, here this is of uh, mm, here Cn and here CH3, and O is bond is withdrawn in this way negative, and this negative will get attached to positive, means O is there. With this B, what B is this? With this B, you are reacting with HCN, you are getting this one, and which one hydrolysis? Once again, what you get H plus and water, that Cn a bit earlier I have written and not yet effaced out. So your answer is COH CH3 COOH. Just follow the technique, automatically the result will come and you will get the marks. Am I right? So this is the final result. Benzene COH CH3 COOH is the final D. It is B, it is C, it is D. So answer of 4 is over. Question number 5. CH3 CH2 C double bond OH. I have written in this way. What will be that A? Answer again easy, CH3 CH2 C double bond. In place of OH, you are getting Cl. Am I right? Then you are getting ammonia. When it reacts with this, you are getting CH3 CH2 C double bond of NH2 will come here. HCl will remove out. So this part is actually amide. You know CONH2 is amide group, and this amide group on potassium hydroxide and bromine, it is called Hoffman degradation reaction. Degradation reaction means CONH2 will become NH2 only in presence of CONH2, bromine and potassium hydroxide converts CONH2 into amine only with one carbon less. It is called degradation reaction. So here, when it is amide is there, here you are given bromine and potassium hydroxide. So amide will become CONH2 will become only NH2. So CONH2 will become CH3 CH2, and this part will convert to this. It is degradation. Am I right? So in amine chapter you will get this degradation reaction. So for time being, keep it in your mind. When amide is there, CONH2 with bromine and potassium hydroxide, sodium hydroxide, it converts into NH2. Just you keep it in your mind. So your final answer is CH3 CH2 NH2. So question number 5 is over. Now question number 6 is like this. You are asked to react with thionyl chloride. So once again, you concentrate your mind with this one. So you are getting this. This will remain intact. Next point is ammonia. A bit earlier you have shown it. Hydrochloric Cl will removed out. Cl in place of this we will get NH2. HCl will remove out. Bromine will be in its place. Next place, it is potassium hydroxide and bromine. since it is amide part, in presence of potassium hydroxide and bromine, degradation will occur, amide will become amine. So your answer will be NH2 there. So this is your question number 5 and 6. And the last question is a bit typical, and it was asked in joint entrance JEE entrance mains. A compound A upon reacting with ammonia gives B. On heating with B gives C. C in presence of potassium hydroxide with bromine gives CH3, CH2, NH2. The thing is that how can you assume the what is A? You are asked what is A. A upon reacting with ammonia gives B. B on heating gives on heating B gives C. C in presence of potassium hydroxide reacts with bromine, it gives CH2. One important point trick I am showing you. Then you are asked potassium hydroxide and bromine to give amine. Means potassium hydroxide and bromine, when this reagent is used and it is asked that you will get amine. Am I right? That means that it is nothing but Hoffman degradation reaction where one carbon is lessened to this. A bit earlier I have mentioned CONH2 groups becomes amine in presence of potassium hydroxide and bromine. Means somewhere in the reaction there will be CONH2, otherwise at the end of the question bromine and potassium hydroxide gives you amine would not have given. Am I right? So your answer is given CH3CH2 and here amine. What does it mean? That is in the reaction somewhere this part will remain same and this amine has come from amide. That amine has come from amide. Am I right? Amine has come from amide. Again that amide has come from this will remain same. This amide must come from carboxylic acid since it is made to react with ammonia. So your A will be CH3CH2 is the final result part of alkyl part. Am I right? It is intact. And what is that A? I think it will be COOH because it's on reacting with ammonia it gives when there is a lone pair of electron and it is negative and it is positive, that lone pair will get attached this one. So you will get CH3, CH2, C double bond O, NH3 and one hydrogen is equal to NH4 positive. This is negative and this is positive. Very unstable. Very important reaction in carboxylic acid. Find that ammonia get react will give you this. And it is known to you this is minus part and this is plus part, and there is lone pair of electron, it is acting upon this one, so giving attaching in this way. Since it is very unstable, it is A, we are getting B, it is unstable. On heating what will happen, one water molecule will get released. So how this water molecule will get is, so you remove one hydrogen from here and one oxygen from here, so that you are releasing water. So out of one hydrogen there is two hydrogen left and N is same as N. One hydrogen has already released, so CO is left and this CH2 and CH3 will remain intact. This part is same, this part is same, and out of this part water has been released, to get this one. So now is it not amide? So that amide when reacting with bromine and potassium hydroxide, it is Hoffman degradation reaction. So CH3 CH2 amide will become amine, and this is the final product CH3 CH2 NH2. So your question answer what is A is ether propanoic acid, and this is the trick in the back where I have shown you from this to this to this. I have shown you how to get the answer. Hope this class will make you interesting. Hope this class seems to be interesting to you, and in the next class I will start with another type of the reactions with CO and alkyl part and along with COOH, and bit by bit I will complete within one or two sets, set number 16 or 17 I will complete this one. Thanks a lot for watching the class, and please don't forget to subscribe the class those who have already not subscribed the class.